Greetings Calc 2 students. This video is an introduction to section 7.7. 7.7 is the approximation of integrals. So I'm going to start off by a simple example. Let's look at the situation where we have the function y equals x squared. So I have y equals x squared, and I've drawn it over here in my graph, only the positive part. And I'm asking for the area underneath y equals x squared from 1 to 4. So from 1 to 4. And I've drawn that in here in yellow. So that's a straightforward question. I would have little trouble answering that. So I would set up the integral from 1 to 4 of x squared dx. And I did that because I started with 1. And I went to 4, and then x squared is the function, and then dx. And so when I evaluate that integral, I'll have x cubed divided by 3, and evaluate that from 1 to 4. This is the antiderivative of x squared, and this often gets this notation of capital F. So when I finish this problem up, I would have 4 cubed divided by 3 minus 1 cubed divided by 3, which is equal to 64 divided by 3 minus 1 divided by 3, which is 63 divided by 3. And 63 divided by 3 is equal to 21. So the area under the curve, y equals x squared, from 1 to 4 is 21. Okay, let's look at a little bit different example. I now have the question of y equals e to the x squared. And I'm looking for the area from 0 to 1. So I've drawn just the positive part of y equals e to the x squared. And I've shaded in the region in yellow from 0 to 1. So I set up the integral the same. 0 to 1, 0 to 1, e to the x squared, e to the x squared, then dx. But the problem is, I don't know what that antiderivative, that capital F, is. But the area still exists. So even though I can't figure out what the capital F is, that area still exists. So then the question is, how do we find that area? Well, one technique we can use is to approximate the area. So this is not exactly the value of the area, but it's an approximation. There are several methods to approximate. You could study more of them in other classes, but in this class, we're going to study the main three. The three we will use in this class, number one, is the midpoint rule. The midpoint rule gets the notation capital M sub n. And that's approximately, not exactly equal, but that's approximately equal to this integral from a to b. The second one we'll use is the trapezoid rule. The trapezoid rule gets the notation capital T sub n. And again, that's approximately equal to the integral from a to b. And then finally, what we'll use is something called the Simpson's rule. The Simpson's rule is the notation of S sub n. And finally, that again is approximately equal to the integral from a to b. I want to point out that these three get a lot of use in other STEM fields, specifically in engineering and in chemistry. Each of them has their own merit, and as computer systems develop and the speed of computer systems develop, each of them actually has advantages over others in certain circumstances. I will make videos about each of these three and the techniques that to solve using these three, but this video is just an introduction for why it is that we have to approximate things and the three main techniques that we use to approximate.